Hi guys, welcome everyone. I'm Jose Leandro. I will talk about dev containers. Here, this presentation is in the context of online tech talks here at YPrompt. So hope we can share a useful tools for you to the everyday. And so please, in case you are not subscribed to our channel, please subscribe so you can be aware of all these talks that we used to do every week. So going directly to the point, today we will talk about an extension from Visual Code that with the name the dev containers. So the main idea here is to create an environment that will be created through a container. So in the daily basis, what we used to do is to create a container for our project that we are working, and that's fine. But we have some issues when we want to try to interact with that container. Let's say with our IDE, like the Visual Code. So here, this extension, what it does is to create an intermediate container to interact with our application. So on left side, it's like the way that we used to work in our local environment with Visual Code. Here we can install extensions and we can install look and feels with themes, and as well we have our source code that we can just clone from a repository. But once we start working with a container, we have like different places into our machines. So the main idea here is to create like an intermediate layer where we can interact with our own containers. So here, what Visual Studio offers is what they name dev containers, and what it does is to create a container to run Visual Code within that new intermediate layer, where what we can do is to customize our environment. And that means that we can install, for example, different tools that we used to use, but in a special linters for the language that we are using and the specific version that we are using. And as well, we can install like everyday tools that we love to use. Maybe some of you maybe wants to install like packages to lint like end of line spaces in the end of line, or we want to have a linter for a specific version of our language. Let's say Python 2, Python 3, Node 6, Node 8. Maybe we have differences in the way that we lint, the way that we build code. So if we do all the things between different projects, we will face like an issue, because we will start having like collisions between different kind of linters, and as well our environment at the end will start like a mess, because it has a lot of tools, a lot of extensions, but mainly here we don't have a direct way to interact with our containers. So the plan here is to enable an environment that has the ability to start with several tools, extensions, look and feel, and as well, if we can store that configuration in a file, as well, we can share the environment to different partners. And every time that we clone a project, we will start from an environment that it's ready to start working with the linters, with validations, with debugger, with let's say that we have Bitbucket pipelines that we like live share. Instead of just doing like a real sharing between us, we can just install like main dependencies that will be shared between all the developers. And as well, we have one of the greatest things is to debug inside into the container. One thing that we cannot do if we are using like a traditional way. So here, this is like in general the main coordinates about this tool, and here you will find like documentation that it's pretty detailed about what it can do. So here we will have different ways in which we can interact using dev containers. I prepared an example, a real example, where we will find a project that has Docker file. It will have as well a Docker Compose file, and we will start using that approach. But as well, we can use the same tool to, for example, interact with an already running container, or we can clone a repository that already have a Docker file, and we can just clone and attach to clone that repository using the dev container. So that being said, I will start just showing how this tool works in real life, or at least in this example. Please let me know if when I change the screen, you can see my Visual Code and the Docker desktop, please.
You can see it.
Okay, perfect. So here, of course, we are looking at the Visual Code, and as well on the right side we have Docker desktop, where we can see that like the logs of our containers. But please take a look in case you was not aware. Here on the left side at the bottom, we have the dev containers, and it says OTT work env. This is the way that Visual Code tell us that we are in the context of a dev container, and we have as well most of the functionality, because we can still working in the same way using Git, for example. We can do a commit, a pull, and etc. We have all the functionality, but within the dev container. And for this demo, what I created is an application that here what we have, it's a Nest application with GraphQL. In special, I created, this is just very simple. It's an entity that then with an entity for a profile that has a first name and a last name. So far, so good. What I'm trying to show here, this is running in the debug mode in a board like the 3060. So if we go to a resolver, it's a kind of controller within GraphQL, if you are not aware about that. And here we are retrieving like profiles. So in case we want to use a debugger, we can just include a breakpoint here into the profile debugger. So when we do a request over a special port that it's using for debug, we will arrive to, as you can see on the right side in Visual Code, where we have all the variables and a context to do a debugging. That is one thing that we have. Then as well, in case you was not aware about this, to make this happen is like in traditional way that we use the debugger. So we need to include a definition of the command that we want to run and abort. And once we have our project, we can just use the debugger section here and start a new services here at this port. And then if that is one thing, is the way that we can interact with our containers. If we stop, of course, we don't have anymore our debugger, and the application will start listening on its default port. In this case, this 3100, and here we don't have the debugger running. It's just the application. So the tool here I just want to see these two examples. And for example, as well, we can go to any other file here in this particular framework on language, and we will have like the autocomplete and every other things that we have installed the project in our file system. But here, remember, we are within a container and we install all this library in the context of a container. As well, another thing here is that we are storing like those dependencies into volumes. So for example, we have to, in order to run this project, we have a couple of files. Of course, the core will be the Docker file, but as well, we have the Docker Compose and Docker Compose override because we want to execute and have other tools in parallel to our projects. For example, we can have a database, we have the backend itself, and as well, we can have other tools, like, for example, in this case, is a kind of database UI where we can interact that with the name Prisma Studio. But here, I think the important thing here is that we are configuring our development environment. So once we start a dev container, we can have all the tools we need to work locally. Like that could not be the case when we go to production, because all these tools used to be like strongest pieces with services with in AWS with more powerful features. And another thing that I want to show here is as well in the context of an override that is our development area. We have some volumes where we store like dependencies for, in this case, Yarn, node modules, but could be, we can have something similar. For example, we use Python, it will be the place where we store the pip dependencies that we used to use. And if we go here to the volumes, for example, let's see, these examples has named dev containers, and we have here 2 volumes. Each volume has it's almost more than a gigabyte. So in that way, we can avoid to reinstall all the packages every time. We just can include a new dependency because we store all the previous packages. We just want to install a new library, like a cryptographic or AWS library or what else. So I am going like from the end of the path to the beginning, because I think maybe it could be more clear what is the purpose of the tool. So here and to give some context about what we are seeing a project, and we have a Docker file that it's our core, but we are talking about here a way to interact with our containers and a way to interact and change and do any kind of change into our files and see how they update into the containers. So in case we want to use these tools, what we need to have is some configuration files. The main file is this one. The name is dev container. And if we saw how our project is structured here on the right side, we will have like special a special folder structure, depends on our project, but we will have these 2 folders, and that they are the ones that we are using right now. The first one is the dev container, that it has like 2 main files. The core is dev container JSON. Then it's a kind of JSON file where we can configure some things. Well, we have the name of this container that represents the Visual Studio. In this case, in our project, we have a Docker Compose, so we have here a way to use like several Docker Compose files in order to customize our development environment. Because, for example, this main Docker Compose file could use, for example, the main backend service, but when we include the override, we can include a database, Redis, cache, and etc. So we can enrich our environment, and we can just start the project and will just work. Then here we are pointing to the service that we are interested in the project that we will start using within the dev container. In our case, is the backend. Or if you remember, when we inspect the Docker Compose override file, we have like two main services, the backend and the database. In this case is Postgres. So the dev container, what it does is to create an environment with different services, and in special, we want to work with the backend right now. And we can then as well do some changes over our initial configuration. We can change the workspace folder and the user as well. We can change it. And here is a list of the extension that will be installed once we start the dev container. Here we have like special, in this case, for this particular example, we have extensions for Prisma. Where else? We have Dockerfile, the lint for a linter. We have Git extension. We can include different things. The way to include the extensions here is once we are here, and for example, we go to, we find something that is interesting for us and for the team in general. We can go here and click on the wheel into the extension and copy the extension ID. This is a way to do it. And as well, we can here add to our dev container JSON file. So once we click here, we will arrive and see how the new extension was added here. And if that is not working, we as well we can paste the extension ID that we previously copied into the extension. And then as well, we can have some create commands in order to customize our environments. The main use case here that I was seeing is to, for example, to install Git on our containers or to do some customization. Sometimes we need to include a special library to make an extension works. For example, sometimes we want to generate like a new ML or ERD diagram, and we need to graph this, and we need some libraries that does process to create images, or we need to customize some library into the system in order to use a development tool. So this is a place as well to put these other commands. And here as well, we have a Docker Compose file where we can customize our environment as well. Here, the place of this file is within the context of the dev container. But in case that a complete team is working using this approach, maybe you can talk about to have something similar like this, because one project could have a service that we can just have a backend with a Docker file with some initial configuration. But once we want to work with our project as a developers and we want to include more functionality, then this is a way that a possible way that this Docker file could look, because we will add our services like a database, and we can as well include this Prisma Studio, and we can see how it works. I hope it works. I will include it, and we will see how it works in the next time we build the dev container. So that is a way to to create an environment and as well to share, because this type of file used to be part of the project. And the other file is more lateral, let's say, because includes the way to run a debugger into the system. And in this case, what we are doing is to call a command with yarn to start our application in a different port. Okay, looks like we are under attack. Okay, we are safe. So the way to interact as well with the dev container, at least, is to with this shortcut, press F1, and we will filter all the commands with the dev containers. So in this case, we want to close the remote connection, and we can then go to our workspace. In this case, we have the dev container project, and maybe it's interesting because if we open a file of a project, for example, this one, or let's see, this over. Maybe I have installed in the system some libraries, and because it's finding where I installed it. But if we clone our project, we used to have like errors because the libraries are not installed. So we need to install in our system. So it's very common and common to see like how the linter says like, warning, this library is not installed or not available. We used to see projects like this when things like this when we clone the project the first time. So here, as you can see here in the left side, we have this green box, and here we can use it as a shortcut as well to open the dev container. Once we call this functionality, we'll call to the dev container file that we saw. So here we can use reopen in container, I think. Let's see. Here we will start a new instance of Visual Code. Here you will see on the left side opening remote, and you can click into the logs of the dev container to see how in this case our container is in its building. So here we are. And sometimes it's when we are creating our environment, it's very common to have issues because our Docker file is not enough. It's not ready, or we have an issue in our Docker file. Maybe at that time it's better to just use a Docker directly, the Docker Compose command, to understand what is a problem with a container image before arriving to a dev container. And if you remember in the last, when we outside the dev container, what we did is to use this file and uncomment this Prisma Studio. And in this case, what we did is to open a new port into the project, that things we are configuring that things from an environment variables. And so, sorry, let me see. No, it's not open here. No. Yes, Prisma. I think that is because, I'm sorry about this. I think in the, oh, here. I'm sorry. Here in this particular project, I have an issue with the environment variables. So I think the problem, because with the Prisma Studio container, is related to an environment variable that doesn't arrive to the Docker Compose override file. But what I want to show here is just And give me a second. We have the containers. Yes. Let me see. I think. Load the window. We should see here on the left side one more service, one new container executing the Prisma Studio. Maybe in the meantime, we are good. It makes sense in general. Do we have any questions? Are you using, any of you is using Dev Container in a different way, or make sense?
I haven't tried the containers, but I have used Docker Compose. Is it possible to separate like environments? Let's say, for example, that I want to test something for dev and something for an staging environment. Is there a way to differentiate that using this extension?
Yes, in this particular project, we are talking about a dev extension that it's independent of environment, and the way, at least in this example, the way to control, I think the way to control the application here is to using the environment variables. So if you have, for example, a different station that has like, I mean, you are talking about all of that locally, right?
Yeah, yeah.
Okay.
But sometimes you don't use dev dependencies, for example, if this is a project on Node.js. So sometimes the dependencies can change across environments.
Right. In that case, maybe you have options. It's not a matter of the tool, but you can have, for example, different Docker files for each environment, for example. And so I think the way what we are talking is here, for example, we have some customizations to run. In this case, they are Linux system commands. But in case you have, for example, as you mentioned, like different tools or libraries, you will have the way to do that, doing a compose of different compose files. So please take a look here. When we are calling the dev container, we are composing a same service from different files. So for example, here we are defining our backend and saying, well, our backend looks like this. But once we are using the override, which is our development environment, we extend that definition for the same service. And that is one thing to customize for. We have that two ways to customize the service itself, and if we want to have environment variables, we can as well use environment variables. And if not, I think we should have like different package JSONs, or like maybe a kind of same similar process with our dependencies. But I think used to be like very similar. I think
I think using the override file for Docker Compose is a good alternative. Yeah.
In this case, in this case, the tool that we are talking, it's more focused on local development and a way to interact to our containers. I think then in a project, I think stations, test, and production should have like a pretty similar look and feel and dependencies and files. I think the way we can control our remote environment is using environment variables, but I think that is a different topic of parts of this tool. So Well, finally, maybe if we don't have other questions, what I did is to create this project that we are seeing right now. It's an empty template. In this example, it's a Node.js, a Nest.js application with GraphQL, with Prisma Studio, and etc. It's empty with just a fake entity named profile, and it has all these files that we are seeing, and you please feel free to download it and test it and play yourself. Maybe one last thing in regards to this environment, if you don't have any other question, or I want to talk about these two variables in special. Sometimes, for example, here I am using an MWAC machine. It's an Apple M1 machine, and used to be that in our projects and in our teams we have Linux, we have Windows, we have Mac, and we have the same containers. And as well, I think part of this tool is to offer a way to a complete team with different technologies and with different architectural CPUs to a way to create the containers that fits on each particular architectural. In this example, we are seeing like these containers are built using the ARM CPU, but we can use AMD or Windows as well, Windows systems. And I think it could be a good approach. Actually, on 2022, Dev Container have some limitation using like the build kit that Docker offers, because there is like a not complete feature with this name, with the name build kit in Docker, that allows us to understand what is the system and the CPU that we are using and do some customization over our Docker file. But I face some limitations when we are using the Dev Container, because that build kit is not working as we expect. So what we end here is to include these two variables. So for example, if we are defining a service, like in this case Postgres, depends on those variables, we will take like an image of the container that comes from ARM or AMD. So that as well is a very good approach, because we can share like this same structure, let's say, between different kind of developers, different machines actually, and we have control to reproduce like issues, or I think that is a good thing. It is not only for one single developer. Maybe it's a proposal so we can spread this pattern, so everyone can build a project with different technologies. And as well, as a final note there as well, sometimes we need to do some customization over the system, because in special with M1 machines, and sometimes we need to install a special libraries in order to use another extension or something similar. BuildKit has an options to install those libraries in layers, in different layers, so we can avoid to have like a huge final container image. But with using this approach, we first avoid to use the BuildKit as well, because maybe in our pipelines we can have some limitations, or is it not a good practice to use like a not final feature from Docker in production. So as well, this is a different way to do a workaround over that. And as well, another final comment about that is in production, all the ARM instance are cheaper than AMD. So as well, if we adopt this kind of approach, we can reduce the final cost of our customers. Well, in general, we talk around dev containers, maybe a blend of things, but I think you will have this project running. I think I will need to move to the YPrompt repository, but it's a proposal. Probably Docker will improve, of course, and will offer out of the box a better way to handle this kind of differences between the architecturals of the CPU. But well, I just want to share this way that we can structure a project using containers, and I think that's it. If we don't have any other question, I think it's the end. Well,
Very interesting tool.
Yeah,
Thanks for
thanks,
sharing.
Jose. Mhm.
Sure, you're welcome. Well, guys, thank you for your attention. Sorry about the presentation. Don't have enough time to build like slide. I was focusing into having an example so you can see a live example, and then you can play and read it. So thank you, everyone. So see you the next one. Bye bye.
Thank you, Jose. See you guys.
Yeah,
Have a nice
thanks.
weekend.
Thank you.
Bye bye.
Bye.